Hey everybody, thank you for coming. I refuse to entertain any conspiracy theories that I cut the power of this entire block so that you would all have time to wake up and come to my talk. So thank you for being here. It's totally unfounded. If you want to follow along with my slides, I need to show off, so I put them on GitHub so you can follow along there. In Chrome sometimes the images get bumped downwards, so if you hit refresh it fixes itself magically. I don't understand. Yeah. All right, so my talk is titled Designing Hypermedia APIs. So this is where we're going to be discussing today. First off though, myself. Hello, I'm Steve. If you're not aware of the things that I do, I primarily hack on Hacky Hack. It's a project that Y used to run back in the day that I've now taken over. It's the easiest way to learn programming via Ruby. So it's really fantastic, and I really enjoy bringing programming to new programmers. Also on the education front, I teach classes with Jumpstart Lab. We run the best Ruby and Rails classes in the world, so if your team needs to level up, give us a call. We'd be more than happy to do some training. So I really love teaching with Jeff. It's really fantastic. So this talk is sort of a collection of this journey that I've been on for the last 8 months of my life or so. One of the things that I hold as a personal goal is to always be learning new things. So I sort of have a list in my head that whenever I think about something that I want to learn, I file it away as, when I have time, go look up X. So I heard people who knew what they were talking about say things like, oh yeah, well Rails isn't actually RESTful because real REST is something else. And I filed it away in the back of my brain and I said, okay, like these people are smart, I should investigate what they have to say. And eventually one day I was bored and I saw someone say that and I said, fine, all right, today's the day. I'm going to actually go learn what REST actually is. So this is sort of a little bit about that journey and bringing that information to you guys so you can also know what real REST is. Unfortunately though, the conclusion I've come to is that REST is over in the Portlandia sense, if you've ever seen Portlandia. Basically, we saw that great talk about communication yesterday, and if you begin communication with argumenting, or if you start by telling people that they're wrong, they instantly shut off. So it's not really productive to continue this REST versus like real REST argument. Basically, REST has turned into not a meaningless buzzword, but a buzzword that means something different than Roy Fielding's dissertation. So some of the people in the like RESTful, the Restafarians, the REST community have sort of decided that it'd be much more productive if we just abandon the term REST and come up with a new one that means something that's a little more obvious, and that sort of eliminates this communication barrier about arguing from the start of any conversation. So we've sort of rebranded this to Hypermedia APIs. So in the rest of this talk, when I say REST, I will generally be referring to Rails' idea of what REST is and not actual REST, and I would sort of encourage everybody else to continue to do the same. There's been an O'Reilly book published with Hypermedia API in the title, and so I consider that to be legitimate enough, and now my book that I'll talk about a little later is also using that nomenclature. So if you could all assist me in just say we're RESTful when you mean what Rails does, and if you decide to join me on this Hypermedia quest, don't argue with people about what REST means, because it's not productive, and we have better things to do with our time. So yeah, so REST, totally done. So if you want to follow the real RESTful religion, which I'll talk about in a second too, Hypermedia APIs is the new preferred nomenclature. So what exactly are Hypermedia APIs? Before I give you my own personal definition, I want to give you a summary that I came up with, a summary that Roy Fielding came up with, and then my summary of Roy's summary. Basically, the reason that you would want to build a Hypermedia API, the advantage that it gives you, is that Hypermedia APIs scale better, more easily changed in the future, promote decoupling and encapsulation with all the related software engineering benefits that those two qualities bring in a code base. However, on the downside, it's not necessarily the most latency tolerant, And cache invalidation is a very hard problem, and caches are used extensively in this kind of architecture, so that's difficult. Also, on an individual request level, it may not be as efficient. If you come up with a custom binary protocol, it will probably be more efficient on a messaging level. So if you compare, like, CouchDB uses a RESTful interface via text, and MongoDB uses BSON, right, which is a binary JSON format. So Mongo tends to be more efficient on the per request level, if that matters to you. It doesn't matter to me usually. So that's sort of my summary on why you should care about this topic. There's a couple sentences about what this kind of API design brings to you. Roy Fielding says that REST is software design on the scale of decades. Every detail is intended to promote software longevity and independent evolution. Many of the constraints are directly opposed to short-term efficiency. Unfortunately, people are fairly good at short-term design and usually really awful at long-term design. So he said this comment in his blog. So effectively, almost all of the criticisms that I hear of REST that are poo-pooing the idea of this, like, Hypermedia APIs, or that they refer to it as religion or as an academic exercise, are basically, they sound to me like the people that say testing is too hard, so we don't do it, right? That's a sort of the same kind of criticism that we've heard in the Ruby community for a long time. We made tools to make testing easier, and we've decided that testing is a long-term value. I write a lot of software that is not tested, and I always regret it later. I've never once written code, well, at least since I learned and got good at testing anyway. Every single time that I don't test my code, I always kick myself later down the line when I try to change something and it breaks. So, so I do this too. We are really, people in general are very bad at short-term versus long-term decision making. So everything is focused towards this long-term design goals. So longevity and independent evolution, the two big things that he cites. So my summary of what this really comes down to is that it's all about coupling. We've heard lots of talks about coupling on the individual software level and, like, why you would want to split out persistence from your business logic and all that kind of thing. We were starting to realize we've done a lot of things in the Rails community and the Ruby community in general that involve heavy coupling, and we've decided that that's a bad thing, but we still build APIs that are incredibly coupled. Our clients and servers are some of the most coupled code that we write. And so this is sort of a large part of this kind of API design is about decoupling your client from your server. So my definition of a Hypermedia API is two things. You use HTTP properly with a little asterisk, and use Hypermedia to guide clients through your business process. There's the asterisk there because technically you can use any protocol that you want. However, in the real world, nobody uses anything but HTTP to do these kinds of designs. And so until a contender comes along, I'm just going to say use HTTP and not get involved in the details of other theoretical protocols. The reason that we use HTTP properly, if you take the constraints, so Fielding's dissertation describes constraints on an architecture that give you certain benefits and you give up certain drawbacks. So these are all of the constraints. There are these six, and a uniform interface constraint has 4 sub-constraints. So this is a lot of stuff, and if you use HTTP properly, then you get all of that stuff for free, basically. There's a couple tiny areas, mostly around cookies and some authorization stuff, where it's not perfect, but largely, if you do what Rails does, and this is why the RESTful APIs are so much nicer to work with than the older kinds of APIs that we tend to use, or the random APIs that people built before, like Rails brought the idea of RESTful things to most web developers. But you get all of that stuff, and I'm not going to talk about what that stuff is because I don't really have the time, but, like, the only constraint that you do not get is the Hypermedia at the engine of application state constraint, which is the second rule in my 2 rules, basically. Use Hypermedia to guide people through a business process. So HTTP is awesome, and you should learn more about it and use it more effectively. And you can subvert HTTP while doing things that are still technically correct. So this is why I have to mention use it properly instead of just use it, because, this is totally a valid HTTP request in form, but not in spirit, right? So part of GET is that GET should not change state significantly on the server, and this would delete photo 12, and that's a bad idea. So this will technically work and is technically HTTP compliant in a certain sense, but it's not following the non you can't validate, your server cannot validate that you're not changing state. So you have to handle that part of it. So this is why I say using HTTP properly. I want to get into 5 steps of designing an API this way. But before I do, really quickly, I want to address this really interesting thing that I've been thinking about a lot lately, which is this sort of religious connection, Rastafarian, and people talking about Rest being academic. So one of the really interesting things about this particular charge about building APIs in this way is that you'll hear people constantly say, like, well, the web is the best example of a hypermedia system. And people sort of like shrug that off in certain ways and say, well, oh, you can only use get and post in web browsers, so like I can't possibly be RESTful. And that particular charge is irrelevant. But basically the largest information system that mankind has ever built works in this fashion. So to give you, I guess, an example, Google in 2010 ran about 6% or 7% of the web's total traffic. That's the largest single organization on the web. Now, Google has scaling problems such that they only allow 3 languages, Google, C++, Java, and Python. And over the last couple years, they've started discouraging the use of Python because it is not able to handle the amount of scale that Google has. This is not a knock on Python. Obviously, Ruby is not up to the challenge either, but it's just illustrating that the largest single entity, which is 2 orders of magnitude, between 1 and 2 orders of magnitude, smaller than the net the web as a whole, has scaling problems to the point where they can only use 2 languages. So essentially, all of these design constraints are about enabling this sort of massive scale, like web scale, while kind of a funny meme, is also sort of really true. The web is too large and made up of too many different components for us to really even comprehend it fully. And so all of these things, if you want to have a distributed network of nodes, then you can't have coupling. It's not possible. You can't, a system that is too coupled will collapse under its own weight at the size of the scale that the web is. So that's sort of why you hear people refer to the web in sort of this like reverent manner of like, well, we should be building clients more like web browsers is one thing you'll hear people say, or talking about, well, the web is the perfect example of all this. And so I'm sort of terming that web worship. There is sort of a little bit of religious fervor, but I think it's for good reasons. So anyway, so after that, 5 steps about designing an API this way from the server side. So I'm not going to talk about implementing clients, and that's a really big deal. Unfortunately, I don't really have the time to fully get into all the details of all of this. So a lot of this will raise more questions than it answers, and I encourage you to come talk to me about those questions later. Half an hour is not really enough to give this topic any kind of justice, because essentially, in order to design an API in this way, you have to forget everything that you know about designing APIs on the server side and on the client side both. It's a totally different way of restructuring things. So a lot of questions that I get from people are sort of trying to fit the old thoughts about building clients and servers into this style of design, and you really need to like fully embrace it in order to get the benefits. So I'm going to talk about an example of building a server this way, and clients will have to come later. So there's basically 5 steps. The first one is to evaluate your business processes. The second one is to create a state machine that represents those business processes. The third one is to evaluate your media type needs. The fourth one is to either create or pick an existing media type to use for your API. And the fifth one is the magical underpants gnome, implement it. Sort of hand-wavy, easy steps. You'll notice some interesting things about this. I talk about process essentially twice, business process and state machines, and then media types twice. No referencing URLs, no referencing verbs, no referencing that kind of thing. Those things are not actually really all that important. So it's really all about your business process and your media types. So, all right, a wild example appears. One of the hard things about talking about this topic is that it's very abstract. Well, it's not very abstract. It's a little more abstract than we're used to talking about things. So I've been making an analogy lately that hypermedia design is sort of like calculus. It's talking about designing things that are one layer removed from your actual API implementation. So it's been really useful to me as I've spent time researching and reading everything there is to read about this topic. It was very helpful for me to sort of think about this abstract idea of, so the uniform interface encourages visibility. And I'm like, well, what does that mean? And I'm thinking, well, the web works such that we only have 4 HTTP, well, more than 4, but whatever, 4 verbs that we use often. And every
web browser knows how to implement those 4 verbs or whatever. And so that's the like concrete example of this abstract idea. So I feel that examples are a really great way of sort of understanding this abstract. You learn addition and then multiplication and then calculus. You don't try to learn calculus and then figure out how addition works afterwards, right? So, so an example of actually designing an API in this way via these 5 steps. One of the students at Mendocino University, Jaime Anesta, I'm probably gonna say his name wrong, I'm really sorry. I talked to him on the internet more than say his name. But he wrote this awesome gem called W3C Love. And basically, what it does is it crawls your site. It validates all the links. You get a report. So it's really, really nice. If you care about validating your site markup, and you probably should, then this gem makes it really easy to essentially crawl your entire site and tell you what is the matter. Because even if you know a lot about this and you care about this, like I write invalid markup all the time because I'm bad at what I do. Basically, I've been meaning to actually turn this into an integration test where, like, once a week I would run against my whole site and make the build fail if I ran invalid HTML. But anyway, the point is, he wanted to build an API around this, and he had built a very standard Railsy API and asked me what I thought because he knew that I care about this topic. So I sort of built him an example, and I want to share that example with you. As it currently exists, you basically make a GET request to this URL, and you pass in a URI parameter of the site that you want to be validated. And so it will make that request and scrape zeldman.com and figure out all that stuff, and then it returns you all of this JSON, right? Super standard. This is what we're all used to working with. Makes a lot of sense. Tons of data, all the different things you're using. The other thing that he provides is a web pages API. So this allows you to crawl a specific page. You may wonder what's better about this than about the actual official W3 site. Basically, this is what the other call is built on top of, so we decided to expose it as well, and that way you only need one gem, whether you want to crawl a whole site or look at one page. And so it handles it for you, and then if the W3C validator ever decides to change their interface, you won't need to update the gem because you'll be able to use his gem and he'll change it. So it's basically the same sort of thing. Crawl one specific page and the URL goes off the screen because it doesn't even matter, and it gives you the same kind of data back. So the first step is evaluating the business processes. This API has a very small set of processes. Basically, you got 2 things. You have this web pages and this sitemaps. So, crawling a whole site via the sitemap and crawling a single web page via the web pages. So then we need to look at these business processes and come up with a state machine that represents how people go through their processes, right? They're not singular things. In this case, I really like using dot to make state machines because it's textual and it's really easy to make graphs that look pretty reasonable. So this is sort of the initial state machine that I came up with. So you sort of hit the root of the URL, which would give you or the root URL of the API, which would give you all of the things you need to do. And then we have 2 lines coming out. One goes to the sitemap process, and the other one goes to the web page process. They both basically give you forms that tell you how to interact with those 2 steps because you need to template the URL. So doing this step especially, and in general, the process of building these things is as much of an art as it is a science. So there's a lot of tips to sort of get you to that point. So this is kind of a little bit of a logic leap for you guys who are just starting to see this. But again, I only have half an hour. I can't go into all the details, so please excuse a small amount of hand waving. But basically, we have these 2 entry points in the 2 different processes. One's the sitemap and one's the web page. And then we both process those requests and we get to some sort of display that would link you back to the root in case you want to do another process again. So I actually ended up splitting this out into 2 steps. You can sort of see that they're 2 whole separate processes. So I sort of revised it a little bit. So either one's totally fine, but basically that's the idea is that, if you have a more complicated process, you have a bigger state machine, right? So submits a background job and then pulls it to see when it's done, and then, maybe updates some status would give you this more complicated interaction. Again, in presentations, Avdi tweeted something yesterday about you show a code example that's real and people can't follow it. You show one that's fake and people complain that it's not real enough. So there's always this balance. So this is a very simple kind of state machine, and it's sort of pseudo real world, but you can see how this would get much more complicated. Imagine the workflow that your site needs to go through and how you would model that as a state machine. So then you need to evaluate your media type needs. I sort of hinted at this earlier. A couple different ways, but unfortunately, JSON cannot drive a Hypermedia API I'm really sorry about this. However, there is hope. So you'll see some people say this and people get sort of upset. They love their JSON. Lots of the people in the RESTful world like XML, and so people tend to get really angry, especially Rubyists. And I'm like, XML isn't all that bad. I'm surprised that I have not been lynched yet. But XML can't do it either. So that's not what it's about. It's not about JSON versus XML. What it's really about is hypermedia semantics, or like affordances is the term that we use. Basically, the problem with JSON and the problem with basic XML is that there is no way to represent a link in JSON. The JSON spec defines strings, arrays, objects, but it doesn't define any way of creating a link. So this is a problem. Essentially, we need a standardized way in order to represent those links so that we can build our state machine via connections. So there's no, if you invent your own type and then you serve it as application JSON, they can't know which standard you're using without reading your documentation. So the idea is that we create this media type that does these standard ways of doing things like linking. That way they can read the documentation for the media type and know that any service that provides that type, they know how to parse the links. So like, imagine, a website, right? We have HTML. It has a standard way of describing links. If web browsers had to know how every single website linked between pages, it would be total chaos, right? So we need to come together to have this kind of standard, and it doesn't matter which one you use as long as you define it and you tell people what it is. So it's important not to add random semantics on top of other media types, is I guess the point. But so I'll be showing you an example of a JSON hypermedia type, basically. So the serialization format is not the problem, it's the semantics on top of that. So all right, let's actually do this. In this case, I'm going to create a media type. You could also use an existing one, and in fact, this is one area where I'm sort of saying things that Fielding would be sort of a little teeny bit upset with. The idea is that you want to use as generic of a type as possible, so if you can get away with using an existing type, serve it. Basically, everyone wins when we use generic stuff, right? So we use Ruby gems so that other people can all use our projects and build off of our work. If every API came with their own custom type, it would lose a lot of the generality benefits of being able to use the same standardized type across APIs, which is what a web browser does when it hits different websites. It only uses HTML, and then it knows how to deal with all the different websites because we've decoupled the client from the server via the media type in the middle. But in this case, I'm going to create one because sometimes you have a custom need, or it's often easier for people to sort of understand how to build a type customly than it is to use an existing one. And you sort of have to know that those existing ones exist in order to use them. So anyway, as an example, we're going to build one. So as I said before, this is very much an art. You sort of have to like see a lot of existing types and sort of know how this kind of thing goes in order to build them properly. But that's also kind of why it's fun. In a lot of ways. So the two big things that you need in your definition are data elements and these hypermedia controls. So the stuff you want to give to your users and the links and forms that go between them to sort of build this state machine out. So we're going to build this application VND W3C love validation plus JSON type. If you know anything about MIME types in HTTP, you might see application JSON or text HTML or all these kinds of things. So in this case, the VND namespace is used for a vendor-specific type. So we're in the VND namespace and W3C love because that's our organization. The type's name is basically validation, and the plus JSON means that like we've added extra semantics on top of JSON, but this is also valid JSON. So if you don't understand it, feel free to parse it with a JSON parser, and you won't get an error. So this is, the process of making a type more standard is also really interesting. Don't have the time. So if we look at the data elements that we're going to need when we return stuff from this API, we saw all this crap before about created at, scraped at, the URL, all that stuff. So we would basically make a media type definition, and we'd say that for this media type, a response may contain created at, scraped at, all this stuff, and we define here are the things that might come back in a response. You'll note the may, there's actually an RFC that defines the meanings of the words may, should, must, and should not, and all these things, and they're really important. And making things optional is one way that you encourage flexibility. I would love to talk about that more, don't have the time. But so making them optional is really useful. And then as far as controls, so we know that we need to submit a URL with a URL as an argument, so we need to template a URL somehow. So we need some sort of forms mechanism or a way of saying to someone, hey, you need to submit to this location, and it's got to have that template so that URL can be variable. So we say that it might have a forms element, which is an array of objects. They have an href, rel, and data elements, and they have some keys. So we sort of define this is how we're going to build a form in JSON. And this sort of emulates HTML forms in JSON. And then we're going to define two rels. So like following a link with a sitemap form rel attribute will lead you to a resource of the form for generating a request, and processing a form with a sitemap rel attribute, the form attribute rel will give you the actual information. So this is like the two steps of get a form, process that form that you get back. And then the magical step 5 is implement all this stuff. So I have some examples of some responses, basically, and I have some Ruby pseudocode about making the requests. So say we make a request to w3clove.com/API, and we provide this media type, that's our content type we want back. It would give us this at the root. As an example, one possible thing. It would give us this links array, and it would say the website form is here, and the sitemap form is here. So our client would then be able to understand those two things since it's looked at the media type definition and implemented that media type. And it says, oh, I know what those two links are. So it would ask the user, like, which process do you want to go through or whatever? Like, do you want to validate a whole website or do you want to validate an individual thing? And then basically this teeny little bit of Ruby pseudocode at the top is basically, grab the links part of the response, find the first link with the rel attribute equal to sitemap form, and grab the href out of it, right? So think about that compared to this JSON, right? We're like grabbing the links, grabbing the rel that we want out of the list, grabbing the href attribute. So we would take that URI and we would submit a request to that one. No constructing URLs. The server has given us its preferred URL for us, and we just follow it. And we also say, hey, we still want that validation type. So it gives us back this new response, and this contains a form with the rel sitemap, and it gives us that we want this name and this value. So we sort of would fill in that name and the value with our URL and send the form to that, post the form to that href. And then that would essentially submit the form, and we get the type back with all the data like we had originally. So this is sort of the basic process of going through one of these kind of things. Again, a little bit hurried, and there's a lot of details too about how you implement a client that handles this stuff in this way. That's really interesting. So we basically have to think like a web browser. Like your web browser does not know how your web service works. It only knows how HTML works. So if you provide a media type and you code your client against that media type, you've created this seam that allows you to decouple your client from your server, and that enables you to change things in the future. So to recap, these are the 5 steps. Evaluate your business process, make a state machine out of it, evaluate your media type needs, create or use an existing media type, and then implement it. The other thing that I want to say that's really important about these sort of things, you'll notice too that one of the things that Rails does that's really bad, the combination of active resource, or active record, I guess, plus the RESTful router means that Rails encourages us to expose our database tables directly over the web. And we may say like, oh, we don't always just expose our database tables, but 95% of what we do with Rails apps tends to be like exposing your database over the web. And that's a crazy amount of coupling between your data layer, the whole way at the bottom of the database, over the entire internet to your client. So that's one of the problems that this sort of thing essentially solves, is that you need to be not giving people your database schema, you need to be giving them your business processes. So that's one of the big fundamental changes about what your API server provides in this kind of API, is that it exposes your process, not the details about that process. So that's the biggest, I guess, fundamental shift. And you'll see that reflected in these rules. We're talking about processes and exposing them, not about the exact data that we're returning. So that's important. The other slightly trollish thing that I will say that's not trollish, but it sounds like it, is that versioning is an anti-pattern, and versioning your APIs is bad, and you should stop doing it. Now, the problem is that versioning does not scale. So think about IE6, for example, right? So we have this coupling with IE6 has these bugs, and we need to support these bugs, and so we're forced to support this old client forever. And so if you use explicit versioning, then it creates coupling between these clients. It's hard to get people to upgrade, whereas this kind of API uses different mechanisms to manage change. I'm not saying you should break old clients. I'm saying that if you do things properly, you can actually transparently upgrade old clients. And so that's a big topic. That's another one of these things that I just want to mention really briefly before I have to go, because now I do have to go. I'm writing a book about this. All of this research, I put in 8 months of reading things and talking to people and watching stuff and all sorts of things. And so it's called designing hypermedia APIs.com. The alpha is available. Basically, it's the first 15 articles or so that I'm writing in this work to explain these kinds of things, and I'm continuing to update it once or twice a week. So if you're interested in this topic, that is a resource that I'm building to learn more about it. And then this is where you can find me around the web. At Steve Klabnik is my Twitter, steveklabnik.com is my website, the book website again. And then the last thing I want to mention is that one of the best parts I like about Jumpstart is that we open source almost all the stuff that we do. We really believe that the value add that we bring is the training itself and the teaching, not the tutorials. So all of our curriculum basically is up on tutorials.jumpstartlab.com, and it's on GitHub and freely editable and usable. So we've had a lot of contributions from people randomly who've read through our stuff and said, hey, I really like this, and I use it to teach my own class, and here's some feedback from my students, and we've like fixed things. So I've been really excited to sort of shepherd that process along, and it's been really cool. So open source is awesome. Thanks, everyone, and yeah, come bug me later about questions about this, because I'm sure you have a million things to ask. So thanks for being awake. Okay, I have 3 minutes for questions. So I'll ask, if anybody wants to ask me a question right now that you think that I can answer quickly, I may tell you that I can't answer it in 3 minutes, because this tends to happen. So, yes? I'm wondering, is the pattern you described, is that being used by other sites currently? So there are lots of sites that are like approaching really close. So if you look at the Netflix API, they're returning URLs and sort of guiding you through this process. If you look at the Twilio API, it's not totally there, but it's pretty darn close. There's a small little company that I've been talking about called Spire.io that does JavaScript stuff. I'm not even 100% sure what they do, but they have a really great guide about like using our API in this way. So there are people that are building non-browser-based APIs like this, and it's sort of, as people are learning about it, it's kind of growing steam. One of the problems is that the people that are really interested in this topic tend to be heavily involved in the .NET corporate world, and so a lot of people I know have built private APIs that they don't really like for clients that they can't talk about. So I know one of the people that works at Comcast, for example, uses this kind of API for a lot of their internal work, but like that is not accessible to the public whatsoever. So, yeah. Basically, so browsers present things to people. API clients are not people. Therefore, how is a like machine client supposed to learn how to use a new form without being a like strong AI, effectively, right? So this is a very complicated answer that we can talk more about later, but basically you can break things down between machine-to-machine processes and human-machine processes. Like if a human does need to intervene in the steps, then the API presents those steps to your user, and so you use those steps to drive even your UI, right? So this is what the browser does, is it stops at every point it needs a human intervention, and they're able to pick that up. You're not going to be able, without like AI, to make machine-to-machine interactions be able to learn new things, but by coding your client in such a way that you ignore new information instead of erroring on new information, you can provide those kinds of things to like human-driven or new clients while letting the old clients like essentially ignore the new stuff. And also, so this is one of the advantages about the forwards compatibility stuff. If you do want to add new things, then you're going to be able to enable like human-powered clients to use this new stuff and not necessarily, you're not limiting the machine things. Like one of the problems with versioning is that you limit the human clients to the old stuff, and you don't have a method to expose them to new things without also breaking your machine ones. So like those two interaction patterns are very distinct, and it's under a lot of discussion at the moment. So yeah, is that 3 minutes?
One question. What about versioning your media types?
Okay. Here's the thing. So a lot of people are saying instead of versioning in your URL, you should version your media type, and in fact, I used to be in that camp. The problem is this: versioning of a media type is supposed to be the absolute last response to fixing a problem with your media type. So even there are other ways to managing versions that are not URLs and media types. One of them is including things in messages. So if you look at HTML, for example, like the canonical media type, it has been text HTML since the beginning of time. Even though we have HTML like 1 through 5, it has not versioned the media type, nor needed to version URIs to version itself. And this largely, again, has to do with you build clients so that you ignore stuff that you don't understand. But HTML itself is actually going 100% unversioned after HTML5 becomes a thing. So effectively, there are other like strategies of getting around that problem of like trying to make your changes as backwards compatible as possible, and adding new things that are optional, so you don't break old people's stuff, but you give options to new clients. And we in Ruby are really bad about backwards compatibility, and it's one of the things that I don't like. I love Ruby a lot, but we're used to, and I do this too, used to saying like, well, screw old people, they can download the newest gem, or like, they can add the git line to their gem file and use the head version of my gem because I don't want to release it yet. And so if you take backwards compatibility seriously, there are ways of getting around that problem, I guess. So thanks, everybody. See you later.